Okay, looking at tonight's homework. First question, we have two diagrams. This is the portion Josephine was supposed to paint right here, and the portion that after she completed her task that she painted her finished product. So question A says approximately what portion of the painting was she supposed to paint? And if you can kind of visualize it, a lot of kids in class divide that into fourths, noticing that she was supposed to paint 1/4 or 25% of the picture. Now, question B is that what fraction of her assigned portion, which was the 1/4, did she actually complete? So if we break that back down into our fourth, you can see looking at her one little piece right there that she completed 1/2 of the painting. So it looks like she did 1/8 of the painting, of the overall painting, but they want again to look at the assigned portion. 3 is write a product to know what portion of the mural she actually painted. That's where you get your 4 she was supposed to, multiplying by the half that she did. She ended up painting 1/8 of the entire mural. Looking at the next one, you have a rectangle that's 8 by 6. So you got 8 by 6. If we were going to enlarge it to a 16 by 12, so now your sides went from 8 to 16 and from 6 to 12. Hopefully right there you can find out that it was multiplied by what number. Again, it got larger, so was it 1, 2, 3, or 4, etc. You should be able to picture that right there. If you wanted now to reduce the 8 by 6 by a fourth, what would the dimensions be? So if I come over here, I want to take a fourth of my 8 and a fourth of my 6. The easiest way I would think, kind of like how we split things in half and then in the fourths today. If you were splitting 8 in half, you would have 4. And if you split 4 again in half, you would get 2. So that 8 becomes a 2. And same thing with 6. We divide it in half, which is 3. And if you divide 3 in half again, you would get 1.5. So your new shape would have sides of 1.5 and 2. Going back to absolute value, we're going to focus in on these two numbers right here to find the distance between -3 and 13. So again, putting them in absolute value, you should see the distance between -3 and 13. Where it can get tricky here is 1 and 11, a distance between. Now remember, if you have 1, we would subtract because they're on the same line, and we don't want to end up adding them because it would be 12, and the distance between 1 and 11 would not be 12. So that's how you would set those problems up. Moving forward here, real quick, change the fraction. So I'll just show you again. We've been doing this over and over again. 4 and 4/5. Easiest way, always say multiply it by the whole number, add the numerator. So 5 times 4 is 20. 20 plus 4 is 24. So there's your new numerator. You keep your denominator. Again, if I said how many times does 5 go into 24, it would be 4 times what's left over, 4/5. Kind of see it the reverse way. Looking at 7/17, same thing. How many 7s go into 17? That would be 2. 2 times 7 is 14. What is left from the 14 is 3. Keep my denominator. And again, to go back and check, 7 times 2 is 14 plus 3 is 17. Keep your bottom there. Do the same thing for C and D. Not going to spend too much time going over these. Again, get common denominators for 5 and 4. You can use 20. 4 and 3, you can use 12. 3 and 2, you can use 6. 8 and 6, now we practice this today. You just multiply straight across when you're multiplying fractions, so we would get an answer of 35 over 48, which cannot be reduced. So that's probably the easiest one. But again, do what it says. Hopefully you guys get C right. We had 4 of those on our past tests. So last homework of the 2017 year. So take it easy, and we'll see you all on Tuesday.